Good morning to all. This is Anusha from MSc Physics, student of Regional Institute of Education, Mysore. Here I am going to discuss about the chemical sensors and the catalysis. These are the topics I am explaining in this presentation. Let's see what are sensors. A sensor is a device that detects a physical, chemical, or biological quantity and convert it into a measurable signals. Sensors are sophisticated devices that are frequently used to detect and respond to electrical or optical signals. A sensor converts the physical parameters into a signal which can be measured electrically. For example, temperature sensor, it measures the heat, and pressure sensor, it measures force. Chemical sensor detects gases or ions. Light sensor detects light intensity. A chemical sensor is a device that detects the presence or concentration of a chemical substance and converts the chemical information into a measurable electrical signal. We actually classified chemical sensors based on the reaction. If the sensor is physically reactive, then it is a physically reactive sensor. If the sensor is chemically reactive, then it is a chemically reactive sensor. Take example, if mechanical property changes, then it is a physically reactive sensor. Mechanical property means this could be its softness, stiffness, stretchability, etc. These are changing, then we are calling it as a physically reactive sensor. Other hand, if reaction changes electrical property of an active medium, electrical property means resistance, inductance, capacitance, so on. If these are changing, we are calling it as a chemically reactive sensor. Upon this, direct device is a simple device and indirect device is a complex device. Some of the basic components, those are the sensing material, transducer and signal processor. Let's see what is direct and indirect sensors. Direct chemical sensor utilize any of a variety of chemical reaction phenomena that directly affects a measurable electrical characteristics such as resistance, potential, current or capacitor. Here it is a schematic diagram for direct sensor. If you have a sensor, in this case it is a chemical sensor. That chemical sensor is giving you a electrical signal due to the reaction directly, then we call it as a direct sensor. There is no indirect process involved. Some materials reacting with another material and giving a electrical signal. We call it as a direct sensor. Indirect sensors are devices in which the chemical interactions does not directly produce an electrical signal. Instead, the chemical's effect is first converted into another physical form and then transduced into an electrical signal. Here, first stage is the sensing stage. Here, the target chemicals like ions, molecules interact with the sensing material. This interaction causes a chemical or physical change, not electrical. Then next stage is sensor element. Here it detects the changes such as mass change, heat generation, color change, pressure change or chemical reaction. At this stage the output is not electrical. Then transducer convert the non-electrical change into an electrical signal. For example, mechanical to electrical signal, thermal to electrical signal, optical to electrical signal, and last electrical signal output. The final electrical signal can be easily measured, displayed using electronic circuit. The analyte does not directly affect electrical properties like resistance or voltage. Here, an intermediate transduction process is required. Electrical sensors are chemical sensors that detect chemicals by measuring changes in electrical properties such as resistance, current, or voltage of a sensing material. When a chemical species interacting with the sensor surface, it causes charge transfer or surface reaction, leads to a measurable electrical change. These sensors are widely used because of their simple design, high sensitivity, and fast response. For example, metal oxide gas sensors, pH sensors, electrochemical sensors. Let's see a working of a gas sensor. When a metal oxide crystal such as SnO2 is heated at a certain high temperature in air, oxygen is absorbed on the crystal surface and a surface potential is formed that inhibits electron flow. When a surface is exposed to reduced gases, the surface potential decreases and the conductivity measurably increases. The relationship between the film's electrical resistance and a given reducible gas concentration is described by the following empirical equation. The equation is Rs equals to A into C to the power of minus alpha, where Rs is the sensor electrical resistance, A is a constant specific for a given film composition, C is the gas concentration, and alpha is the characteristic slope of a Rs curve for the material and the expected gas. Mass sensitive sensors operate by detecting a small change in mass due to adsorption of chemical molecules on the sensor surface. These mass changes causes a shift in the resonance frequency of the sensor material. For example, quartz crystal and surface acoustic wave. Thermal sensors are chemical sensors. It detects chemicals by measuring the heat released or adsorbed during chemical reaction on the sensor surface. The temperature changes modifies electrical properties such as resistance or voltage. It is based on exothermic or endothermic reaction. It uses temperature sensitive material. It has very simple working principle and it is reliable for combustible gas detection, and it is moderate to sensitivity and fast response. Examples are catalytic bead gas sensors, methane and LPG gases. Magnetic sensors are chemical sensors. It identifies chemicals by detecting changes in magnetic properties like magnetization when chemical species interact with magnetic sensing material. For example, magnetic nanoparticles based on the gas sensors. Next, coming to the advantages of chemical sensors offers high sensitivity, enabling detection of very small concentration of chemical substances. They provide a fast response and recovery time, which allow real-time monitoring of gases and liquids. Due to their compact size and portability, chemical sensors can be easily used. They are generally low power and cost effective, making them suitable for large scale and continuous monitoring applications. By selecting appropriate sensing material or catalysts, chemical sensors can achieve high sensitivity towards specific target chemicals. They are also easy to integrate with electronic system, enabling automated control data logging. Next, coming to the catalysis. Catalysis is the process of increasing the rate of a chemical reaction. A catalyst speed up the reaction by providing active surface sites and an alternative reaction pathway, but it is not consumed during the reaction. Catalysis is commonly observed in enzymes, heterogeneous catalysts, and photocatalysts. The efficiency of a catalyst strongly depends on its material property, such as surface area, crystal structure. It affects reaction pathways, defects, and vacancies, enhancing reactivity. Electronic band structure, it controls charge transfer. Next, coming to the types of catalysis, there are many types of catalysis. I am going to explain one by one. First one is homogeneous catalysis. It occurs when the catalyst and reactants are in the same phase, usually liquids or gases. The reaction takes place through molecular level interaction, not on solid surface. The catalyst forms temporary intermediate complexes with reactants which lower the activation energy and increase the reaction rate. This type of catalysis offers uniform reaction condition and high selectivity, but separating the catalyst after the reaction is difficult. Next, coming to the heterogeneous catalysis. Heterogeneous catalysis occurs when the catalyst and the reactants are in different phases, usually with a solid catalyst and gas or liquid reactants. The reaction takes place on the surface of the solid catalyst. Reactants first adsorb on the catalyst surface, then react. And finally, the product dissolved. This process lowers the activation energy and increases the reaction rate. The catalytic activity mainly depends on the surface area and number of active sites. An important advantage is the catalyst can be easily separated and reused. Enzyme catalysis. Enzyme catalysis is a type of catalysis in which enzymes act as biological catalysis to increase the rate of biochemical reactions without being consumed. The enzyme binds specifically to the substrate to form an enzyme substrate complex, which lowers the activation energy and speed up the reaction. Enzyme catalysis is highly specific, work efficiently at low temperature and pressure, and is essential for all biological process. Role of a catalysis in chemical sensors. Catalysis plays a key role in improving the performance of a chemical sensor. Catalytic materials enhance the interaction between the sensor surface and target molecules, making detection more effective. Catalysis accelerates surface chemical reactions and lower the activation energy, which leads to higher sensor sensitivity and selectivity. They also provide faster response and recovery times. Additionally, catalysis enable low temperature operation, reducing power consumption and improving sensor stability. Advantages of using catalysis in chemical sensors. Catalyst improves the performance of a chemical sensors by enhancing the reaction between the sensing material and target molecules. They helps to increase sensitivity, improve selectivity, speed up response and recovery, lower operation temperature and enhancing stability and lifetimes. Here ends my presentation. Thank you.